At least 3. Always. Always.
Finally somebody. Oh, because I put 32 on.
I'm going to sort of start catching up to you guys a bit.
I love it being like
Oh man, I gave away all my sheets. Alright, so you guys, help me out. I gave away all my Z-score charts. Did you guys get the Z-score for the first one? Negative 0.56? And then when you look it up, you get what do you get here? 2877? And of course you got to do 1 minus to get the actual answer. So 0.7123. So let me ask you this. What does that mean? What is the meaning of this? 71.23% of women
will have a greater bone mineral density than 2.5.
Beautiful, I love it. You can either say it's a 71.23% chance, but to be honest, it's slightly better to say 71.23% of all women will have a bone density more than 2.5, whatever, gram per square centimeter. You guys, yes, what's up? You alright? Ashley?
I don't know how to do that. The 0.7123. I was already.
Where it came from?
Yeah.
Are you cool with the Z-score? Did you get that Z-score? Okay, and then when you look it up, you get this number from the Z-score chart. That's not the answer though, because I want greater than, so what's 1 minus this? That. I want the rest of it.
Are you going to want us to write this out? Like, are you going to want us on the test to ask us to write, like what you're saying? Like the sentence basically saying this is probability?
I might. I just keep bringing it up because I have been known to ask that conceptual question. Explain exactly what the number from part A meant. I like it. Part B, I changed my standard deviation, right? Because I took a sample, asked a question about the sample mean. You guys. Guys, hey, find a z-score using the new standard deviation. I got negative 3.48. It's almost off the chart. When you look that up, what do you get? 3? So then the actual probability is, so just about 100% chance almost, that a group of 38 women will have average bone density more than 2.5. So guys, if I went to a town and I took a random, and girls, do I have to, guys, every organic entity in this room look this way? If I went to a town and I randomly selected 38 women, okay, now I know who my sidewalks are. I randomly select 38 women, and I find a bone density, an average bone density of 2.4. What would you think? Is that unusual? Let's start there. Hell yes. That's way unusual. There's only that chance of it happening. So there is a chance that that would just naturally happen. But what's more likely is something's going on there. Maybe the water's got something in it, something they're eating, something in the air. Something is causing their bone density to be lower than it's supposed to be. Are you with me? This is kind of like what the EPA does and what these various agencies do when they sample water and so forth. They look to see if it's out of whack, and this is what out of whack would mean. That's out of whack. All right, I like it. Well, let's see. So what about, let's see, number 2, life expectancy. A and B is just normal, straight up z-score problem, right? And why am I allowed to do this? It's normal, I like it. So one probably less than 79. So that means probably that infant would live to be less than 79 years old. So then I can make a z-score. My data point minus the mean. What's the standard deviation?
7.6.
7.6. So what do you get there? 9?
Yes.
All right, I'm just going to talk to a few of you guys. So, when you look that up, what do you get?
0.464.
4641? And do I have to do 1 minus?
No.
No. I like it. So about a 46% chance that the baby will live to be at most 79. All right, maybe.
How come you have to do -1 there?
Because I didn't ask for greater than. The z-score chart, I'm not sure who to look at. The z-score chart always gives me the area below, and this one asks me for the area below. What's happening? I don't understand. So, the z-score chart tells me the area below, and it's asking for the probability less than, so I don't have to adjust it. Part B. Here, you guys can maybe help me to make this quicker. 62, 71. What's the z-scores you guys got? What'd you get for 62 z-score?
Negative 2.33.
You 2.33. For 71? Negative 1.14?
Yeah.
And then when you look up the areas, what'd you get for, sorry, negative 253, start at 233. 0099?
Yeah.
And then 114 negative?
1271.
All right, let me stop there. You guys, I'm going a little fast, but I'm trying to get us out. So then the area between will be, subtract those, and what do you get again? 1172, okay. So about 11.7% chance that a baby will live to be between 62 and 71 years old. Again, that was old news. Old news, before today. And then part B, sorry, that was part B. I don't know what the hell. Oh, that was part B, yes, okay. And then part 2, part A, I love that, Jeff. What the hell? So I take a sample of 87. So what's going to happen there? Standard deviation is going to change. I took 87 infants. They didn't even stop me. So what do you get when you divide those? I don't know. It's like Fallout logic. I just stuffed them somewhere. You cannot run. Sorry?
8.8148.
8148?
Yeah.
I like it even more. And then you do the exact same work we did here, right? So you get the z-score. Well, not here, but here. 79 minus 79.7 divided by 0.8148. Negative 0.86, I like it. And then you look it up on the chart. Yes, ma'am.
Do you find the probability that the sample mean is greater than 82 years?
So again, at the very beginning, I told you there's a typo on the very last problem.
Oh, I've not used it.
See how it says greater than 82, but then look right next to it? So it said do that one, because I wanted to relate it to part A. You see that? The first part? Okay. Alright, so everybody got a practice test, right? Alright, so I'll have that answer key on Monday. I'll have your group works graded. Monday's review for the test that's happening Wednesday.
So, how long is this going to be?
Roughly. Please give me back my calculators. Please.